Hi Rockbridge, this is Mrs. Berger, and today we'll continue with day 2 of our unit on polynomials. Today we'll make use of our synthetic substitution and use that technique to show polynomial division. First, we're going to show you polynomial long division so that you can see the basis for this, and then we'll use synthetic for the rest of the day. So polynomial long division is a lot like long division that we learned when we were in elementary school, okay? So let's take a look at the problem we have off to the right here. 125 divided by 5. So before you had a calculator, when you were asked by your teacher to do long division, what you looked at was you looked at the 5 and you said, how many times can 5 go into 1? And you said, well, 5 doesn't go into 1, it goes in 0 times. And so you brought that 1 down. 1 minus 0 is 1. And then you brought the 2 down and brought that together and said 12. Okay, how many times does 5 go into 12? And you said 5 goes into 12 2 times. And 2 times 5 is 10. And we subtract that 10 from the 12 to leave behind a 2. And then we bring that 5 down and make this into a 25. And we ask the question again, how many times does 5 go into 25? And the answer to that, of course, is 5. Wasn't a very clear 5. Let's do this. Okay, so the answer to that is 5. So the answer to this question is 25. 125 divided by 5 is 25. And there is no remainder, so remember, if we ever had a remainder, if there's any little leftover parts that didn't go in evenly, we listed that as the remainder. So we're going to do some very similar steps to show polynomial long division, okay? So let's set this up like we're used to from the younger days. So we'll have 2x cubed minus 5x squared minus x plus 3. And that'll be divided by x plus 3, okay? So very similarly, we think to ourselves, okay, what goes into, how many times does x go into 2x cubed? Or what could I multiply x by to make 2x cubed? What do I have to multiply x by to make 2x cubed? Just like what do I have to multiply 5 by to make the 12, okay? And of course, you've already thought of this. You're probably yelling at the screen. Oh, it's 2x squared, right? So when we come up with what goes up there, we say, okay, just like the 2 times 5 is 10 in here, 2x squared times x is 2x cubed, which is what we were engineering for ourselves. But don't forget, right here, we don't just have x, we have x plus 3. So that 2x squared plus 3 times 3 has to go underneath here as well. So 2x squared times 3 is plus 6x squared. And don't forget, back in elementary school, we didn't add that, we subtracted that from above to figure out what we have left over to come up with the next step. So 2x cubed minus 2x cubed is 0. Negative 5x squared minus 6x squared is negative 11x squared. Bring down the negative x, and let's start the process over again. What times x equals negative 11x squared? Hopefully you thought to yourself, oh, negative 11x times x is negative 11x squared. We also have to think, okay, negative 11x times 3 is negative 33x. Subtract that from the top. This zeroes out by design. Negative x minus a negative 33x gives us plus 32x. Bring down the 3. And now we start this process one last time. What do we have to multiply x by to make 32x? Of course, that is 32 that we multiply by. 32 times x is 32x. 32 times 3 is 96. Remember, we subtract that from the top. This zeroes out by design. 3 minus 96 is negative 93. So negative 93 over x plus 3 ends up being our denominator. So that's our answer to this long division problem. This purple polynomial divided by this purple x plus 3, the answer to that is this polynomial here. Okay? So that is long division. Now, for purposes of the rest of this unit, I don't need you to use long division. You should definitely be familiar with the steps, but we'll go through how to use our synthetic steps to reach the same goal. Okay? So let's take a look at the insert that you have available to you, showing you how to do synthetic division. So remember how we set up our table. We take the coefficients of our polynomial, so the 2, the -5, the -1, and the 3. And then outside of that, we take a look at what we're dividing by, x plus 3, and use the root. Use the root. So we learned last in our project unit, x plus 3 has a root of -3. So the root goes on the outside there. Use the root associated with the divisor. And then we follow the same steps. Bring the 2 down, multiply up, add down, multiply up, add down, multiply up, add down. And you'll notice we get the exact same answer we did with long division. That answer is constructed by taking the numbers at the bottom. So remember when we did synthetic substitution, we just circled the last number and said, hey, we've evaluated at -3, and the answer is -93. Well, we'll use the same steps, but this time, instead of just circling the last number, we'll take the numbers at the bottom of the table and make those our coefficients. So the 2 becomes a coefficient, -11, and the 32. And the -93 is obviously the remainder. Now, think to yourself, why did I start with a cubic, divide by a linear, and end up with a quadratic? Think about that for a second. Why did we drop the power on these x's? Think about it this way. Back in unit 1, we took x to the third and divided by x to the 1. That's what we're doing here, right? X to the third divided by an x to the 1. And remember what we did with those powers. We subtracted when we were dividing like that, right? We took 3 minus 1. That's exactly what happened here. We took a cubic divided by a linear, and we ended up with a quadratic, okay? So when you have these coefficients ready to go, glue them to the front of x's with 1 power less than they had before, okay? And then anything left over at the end, after the constant is listed, anything left over at the end will be your remainder. If you have a 0 at the end, you don't have a remainder and you have nothing to write after the constant, okay? So this page was to show you that long division problem using synthetic to compare and contrast the two. I think the best way to learn this is to practice it. So let's take a look at some fresh examples that haven't been done already for us, and let's walk through these together. So in the first example, we're dividing this cubic by this linear. If you're dividing by this factor, we put the root associated with that factor on the outside. And then, of course, we grab the coefficients, just like we did with substitution. The coefficient on the front term is 1. Then we have a 5, and a -2. Remember, we don't have any missing exponents. We have a cubic, a quadratic, a linear, and a constant. So nobody's missing in the list, and everybody was already in order for us. So that's why we were able to just straight grab those. Now, let's go ahead and use our steps. Take the 1, bring it down just as is, and then we're going to multiply up and add down. Multiply up and add down. Multiply up and add down. And now, instead of circling that 0 and saying, hey, we've just input -2 into this and the answer is 0, this is a division problem, and the result of a division problem, a cubic divided by a linear, should be a quadratic. So these become our coefficients now. 1x squared plus 3x minus 1 and no remainder. Now certainly you don't have to write this 1x squared. It was just to really drive home the point that the numbers above, underneath the table, are what become our coefficients of our answer. So this right here is your division problem answer. You've divided that cubic by that linear, and you've produced the answer, which is a quadratic. Let's try the next one together. We have everybody in power order, but it looks like we're missing some power, so we need to have some 0 placeholders. So let's get those taken care of. So we have the 2, we're missing the cubic, we have the quadratic, we have the linear, and we have the constant. And then if this is the factor, the 0 associated must be 3. We'll bring that 2 straight down, and we'll multiply up and add down. 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 Now let's construct our answer from this synthetic table. We'll use this tool to construct our answer. Remember to drop the degree. So if we started with an x to the 4th and divided by a linear, the degree of our answer should be an x cubed. So 2x cubed plus 6x squared plus 3x minus 1. Now that's our constant. Remember we have a remainder, so properly notate your remainder as plus 2 over x minus 3. That is the answer to that division problem. And it's pretty messy. That's the answer to our division problem. Had you done long division, you would have come to this conclusion. You would have come to the same answer with long division. All right, let's use this to talk about something called the factor theorem. The factor theorem states that if you have a polynomial and you're told there's a factor x minus k, and k is always some number, and you're said, hey, I've got this polynomial and I know one of the factors is x minus k. You also know that if you put k, that number, into the polynomial, it will spit out 0. That's what the factor theorem says. And what the factor theorem does for us is it helps us link factors and zeros to that polynomial. So let's revisit something that we learned through the project. If you know that 2 is one of the roots or zeros of a function f, you also know that x minus 2 is a factor of that polynomial. And what we're also learning now in this lesson is that also if you were to put the number 2 into that function, answer would be 0. If you input 2 into that function, it would evaluate to be 0. Now this is all fine and good and interesting, but let's make use of this. Okay, let's make use of this. The instructions for this section are to factor the polynomials. So please take note of this on quizzes and tests and homework. The directions are everything. Okay, everything is the devil's in the detail, right? Make sure that you know what's being asked of you so that you put your answer in the right format. The format of the answers for the next 2 problems will be factors, not those long nasty polynomials, okay? So let's watch this play out here. We are told that we need to factor this cubic function in number 1 here, and we're told that k equals negative 2. What they're saying here is, hey, I know that this has a root at negative 2. That's my gift to you. I've already determined that this function has a root at negative 2. You can also deduce that it has a factor at x plus 2, right? So by declaring there's a root, k, at negative 2, you can also think to yourself, oh, that means I have a factor of x plus 2. If I know there's a root at negative 2, that means I can divide out that factor using synthetic division. Why is that useful? Let's see why that's useful. Let's go ahead and divide that out and let me show you why it's useful. Copy your coefficients down. Nobody's missing and everybody's in the right order, so I'm happy with that. Copy your root down, your given root, right on down. Conduct your synthetic. Add down, multiply up, add down, multiply up, add down. Now, what are we left with? If we divide a cubic by a linear, we are left with a quadratic, x squared minus 7x plus 12. Now, you might have the gut reaction to say, oh, let's circle that. That's our division answer. It's true. If we were to divide this polynomial by x plus 2, this would be my division answer. But those weren't the instructions. The instructions were to factor. Well, thank goodness we've already completed our quadratics unit. We know how to factor this. We think to ourselves, what multiplies to 12 and adds to negative 7? What multiplies to 12 and adds to negative 7? You've probably already thought to yourself, oh, I know, negative 3 and negative 4. Now we just grab that factor that was already given to us at the beginning of the problem, x plus 2, and now you have fully factored a cubic function. Think about that. Before we walked into this lesson, you only knew how to factor quadratic functions, right? We used foci, or we determined what multiplies to the last term and adds to the middle one. So we did make use of those skills, but before we could get to a quadratic, we had to get away from the cubic that we started with. And to do that, we used division to take out the given root so that we could get down to a quadratic we knew what to do with, okay? Now, a couple of useful notes I want to make before we try the next example. The first note is, it doesn't matter what order you write your factors in. If you wanted to glue that given or that gift factor of x plus 2 to the front instead of the end, that's totally fine. And you could have listed the x minus 3 and x minus 4 in either order. So the order doesn't matter. Additionally, a little self-check that you can do for yourself is to take a look right here. Before you go any further in these factor problems and the factoring problems, make sure that this is a 0, that there's no remainder before you go into the quadratic element. If there's a remainder, this is not going to get factored. And you know your Algebra 2 teachers would never hand you a factoring problem that can't be factored, okay? So if you're in the section of the quiz or the test or the homework that says factor the following, and you get to the bottom of this synthetic, and this number here is not 0, something probably went wrong with a simple little math error before. So go check your work before you go any further, because in order to completely factor, you need to get to a quadratic that can be factored. Okay, so those are just some notes for yourself as you're going through these. All right, let's walk through number 2 here. So we are told to factor this cubic, and we are told that x minus 10 is a factor. So that also means that k equals 10, we know, is one of the roots. Okay, so we'll make use of that. The coefficients are 1, negative 12, positive 12, and 80. Nobody's missing. I don't need any zeros, and everybody was already in order for me. And I'll take that root of 10. I'll bring the 1 down. I'll multiply up and add down. I'll multiply up and add down. And I'll multiply up and add down. So once again, I have no remainder. I'm on the right track. I know I did all the steps up to this point correctly. I'll construct my quadratic out of the coefficients that I have from above. And I'll think to myself, what numbers multiply to negative 8 and add to negative 2? Hopefully you thought, oh, it's some version of 4 and 2, and the 4 must be negative and the 2 must be positive. Now you just need to take the gift that was given to you in the problem, the gift factor of x minus 10, and those are the factors of that particular cubic. Okay? So the instructions there were to factor, not divide. Okay? Instructions here were to divide. The instructions here were to fully factor. And just remember, k is just our mathematician notation for here's a root that I know exists. Okay, the practice problems that we have to work together start off with a long division problem. I don't want you to spend a ton of time practicing this. You won't have to demonstrate this. But just to get you started, just remember we're trying to think of what can I multiply 2x by to make 2x to the 4th. And that, of course, is x cubed. So that'll get me my 2x to the 4th. And then I multiply x cubed by 1. Subtract it from the top. And think again, what do I multiply 2x by to get negative 2x squared? And the answer to that is negative 2x. I'm sorry, just x, right? Plus x. Ooh, sorry about that. The negative oh my goodness, I can't get there. Negative x, there we go. Negative 2x squared, that matches up with that. And when you have that ready to go, make sure that negative x is multiplied by the 1 as well. And subtract that from the top. So on and so forth. When you finish this out, your answer ends up being x cubed minus x plus 5. So go ahead and practice that for yourself. Again, you will not have to demonstrate long division on quizzes or tests. We want you to be familiar with how it works, though. Let's use synthetic for the rest of this page. Now, notice I have two different sets of directions. Mostly, like I said, it's a reading test, right? Make sure that you're reading the directions. This format says divide this by this, and this format says simplify this by dividing. They mean the same thing. Even though the words are different, we're asking you to do the same thing. Divide it out. And so your answers are going to be in the format of polynomials. Okay? So let's go ahead and use synthetic to do this. I'm missing some exponents here. So I've got a 0 placeholder and another 0 placeholder. Okay. And I'm going to get this set up for you. I would like you to pause the video and try this out. Okay, so pause the video, try this out, and then restart the video to reveal the answer and the work, okay? Okay, hopefully you had a chance to work through this. I want you to take a look at the answer I have written for you. Now remember, this was a division problem. We had x to the 5th divided by an x, so the answer that we have should be a quartic, an x to the 4th. So we dropped the power on everything. We took the coefficients at the bottom of the table and we put them in front of everything. And the last number wasn't a 0, so we did have a remainder. If any part of this is wrong, I urge you to pause the video and find your error. Definitely small math errors throw us off on these things, so pause the video, find your error, look at my work here, and don't go any further forward until you understand what you may have done wrong here. If you're at the point where you have everything matching what I have, let's go ahead and try the next one. Again, the directions are worded slightly differently, but the steps are exactly the same. We're asking you to do the same. We're asking you to divide, okay? And so we'll take our coefficients. We're missing a quadratic term, and that's the only one we're missing. Everybody was in order, and the number I will use outside is a 4. And I'll bring that 3 down, and then I'm going to ask you to pause the video and work out the rest of this and tell me what your polynomial answer is, and then check with my work in a minute. Alright, hopefully you had a chance to pause the video and try this for yourself. I urge you to try this yourself. Don't just copy down things as I'm going through them. You need to try them for yourself and check them in the moment, okay? So your polynomial should end up with no remainders because you had a nice pretty 0 at the end. You needed to drop the degree by 1 because you're taking x to the 4th divided by something x to the 1. So x to the 3rd is your highest power in your answer, and then you just count down a power for each term. Okay? So those were two division problems that we use synthetic division for. Another format you'll see questions asked, of course, is factor each of the following. And so we want to make sure that you factor all the way down. Do not stop at the first step of division. Okay? It's very, very tempting to stop after the first step of division. You need to keep going until your answer is all factors. So let me get you started. We're going to set up our little table here. We know that one of the roots is -5, which we also know is a factor of x plus 5. So that was our gift factor of x plus 5. That'll come in at the end. We'll take our coefficients. Please note that your first couple of coefficients are 1 and -1. Then you have a -21 and a 45. Bring it down, and I'll work this with you because you certainly had quite a bit of practice with this. So let's work this one together. We'll multiply up and add down. We'll multiply up and add down. We'll multiply up and add down. Now, once again, we are so thankful that this is a 0, there are no remainders, because if it wasn't, factoring would be out of the question, right? So factoring is what we've been asked to do. Factoring is what we're about to do with the quadratic x squared minus 6x plus 9. What multiplies to 9 and adds to -6. -3 and -3 should be your answer to that question. And then, of course, we will take our gift factor of x plus 5. This is the full factorization of this question. One of the biggest things folks don't remember to do is factor this last little step, right? A lot of people stop here. Do not stop here. If the question is factor fully, factor completely, we need to not stop at this answer, at this division problem answer, okay? We need to keep going. All right, let's take a look at the next one. The directions are the same. The directions are to factor fully, factor completely. We've been given k equals 1, so we know that goes out here. And we also know, just to record these things, x minus 1 is a factor. That was our given factor. We'll take our coefficients. Everything's in order, no one is missing. We'll bring the 4 down. We will multiply up and add down, multiply up and add down, multiply up and add down. We're pleased to see that there is no remainder. The quadratic that we will factor is 4x squared plus 0x minus 9. I'm not going to bother writing the 0x. It zeroes out and is not very helpful. I'm going to write 4x squared minus 9. Now the factorization of this, hopefully you will notice that this is a special case. It's a two-term special case. Hopefully you're thinking to yourself, 2 terms, what was the factor of 2 terms? Wasn't it a certain special case? Hopefully you see that this is a difference of squares. This difference of squares, a squared minus b squared, right? A is 2x and b is 3, okay? So the factorization of this is 2x plus 3 and 2x minus 3. And then, of course, we'll take our gift factor and bring it in at the end, x minus 1. That is the correct factorization of that question. So again, we're really building on those factoring steps. If you forgot them, go back and relearn them. They will be heavily used in this unit as well as the next unit, so don't let it fall out of your head anytime soon. All right, and so the answers to those problems were factors. Let's take a look at 2 more ways that you will be asked these types of questions. The first way is, given that 9 is a 0 of this function, find the other zeros. Leave your answer in simplest radical form. Well, this is very interesting. This isn't quite like anything we covered earlier, but we will in fact be using the same skills. Given that 9 is a 0, so this is a lot of wordy words to say, hey, k equals 9. Here's a given factor for you. X minus 9 is a factor, okay? So given that 9 is a 0, k equals 9, x minus 9 is a factor. That all is 3 different ways of saying the exact same thing. And when you knew that k equals 9, what did you do with that information? You used that information to divide out that factor x minus 9 and get yourself down to a quadratic that you knew what to do with. Okay? So let's do that here. We need to find the other zeros. Let's see if we can get down to quadratic, because quadratic, we have all kinds of tools for finding zeros in quadratics. So let's make use of this given 9 is a 0 and get it out of there. See what's left behind. Bring the 2 down, multiply up, add down, multiply up, add down, multiply up, add down. So by taking that factor x minus 9 out, we leave behind 2x squared plus 8x plus 1. Now, my instructions are to find the other zeros. Well, at this point, sometimes I like to try to factor this and set each factor equal to 0 to find the zeros. But can I factor this? Is this quadratic factorable? Can I find things that multiply to 2 and add to 8? No, there isn't such a thing. I could certainly take a look at completing the square, although that's not really my favorite with this 2 hanging out here. The most useful tool available to me right now is the quadratic formula. I have a quadratic. I'm being asked for the zeros. Quadratic formula is certainly something that I can use to find the other 2 zeros. Remember the quadratic formula is negative b plus and minus the square root of b squared minus 4ac over 2a. So for our quadratic, that's negative 8 plus and minus the square root of 64 minus 4 times 2 times 1, all divided by 2 times 2. Now, don't forget, simplest radical form. Remember that from the quadratics unit. You got points off if you left your answer in a format that had perfect squares left under the radical. So let's keep going until we know that it's in simplest radical form. 64 minus 8 is 56. We know that there's a 4 within there, so we'll take negative 8 plus and minus 2 times the square root of 56. 2 times the square root of 14 over 4. And the next thing we can take out is a 2 from everything. We'll leave behind 4, 1, and 2. Sorry for the yellow, I will fix that in a second. So we're left with negative 4 plus and minus the square root of 14 over 2. Okay, that's just a recap of simplifying quadratic formula. So if that went too fast, let's go ahead and pause the video and go back and look at that. But that should be a pretty ingrained skill at this point, right? You've been quizzed and tested to death on that one. Okay. So our roots are 9. That was a given root. Negative 4 plus square root of 14 over 2. And negative 4 minus square root of 14 over 2. Those are our 3 roots for that. Okay, those are the other zeros besides 9. We made use of our synthetic division and our quadratic formula for that one. That was pretty intense. Just make sure that you understood what you were being asked for before you dove into the problem. Now, this last question, I'm actually not going to pull up my calculator app to show this one to you, but what you're being asked to do is take a look at this function in your calculator. Go ahead and plug that into your calculator. Pause the video if you need to take some time to put that into your calculator. And notice what this cubic looks like. Try to find all the real zeros after plugging that into your calculator. What do you see as the real zeros from that function? Hopefully you see zeros, and it should look like this, right, in general. Hopefully you see zeros in 3 places. You see cut-through zeros, not bounces or slides. And you should see them at negative 3, 1, and 6 on your calculator. So those are the real zeros for this function. Okay, so this is one more tool in your basket of tricks here for looking at these things. You can always say, hey, I just did all this work with synthetic, and I think I found all the zeros, or I think I found all the factors. You can always put that function into your calculator and take a look. Hey, does it look like those are the right zeros if just looking at the graph? Okay, so the answer to this is the zeros are negative 3, 1, and 6. You can confirm that. You can certainly divide out a negative 1 from the original. You can set up your synthetic and do all that work, and you'll get down to a quadratic. And the quadratic you get down to can be factored into x minus 1 and x minus 6. Okay, so there's all of this is very circular, right? You can prove with the graph, but you can prove with the algebra, and back and forth. So you have these great tools available to you to check your work. Okay? So that's the end of the day 2 lesson. Go ahead and try your homework and ask your teacher if you have any questions.